Pre-processing is an important step as matching the exact string of characters typed by the user with the characters written in the document is too restrictive and cannot be used to train a machine learning model and expected to generalize over the data. Pre-processing also helps us retain important words while eliminating the unimportant ones, as we know that not all words are of equal value in a search. So for information retrieval algorithms, it is crucial to pre-process the text to best represent the information that is of utmost value. Let's shift gears and move towards some technical terminologies. A word is a string of characters that appears in the raw text. It has a certain meaning concerning its location in the sentence and the context of the document. A term or a type is a normalized word. Normalized refers to the case, morphology, spelling, etc. of the word. A token is an instant of a word or term occurring in a document. Type refers to an element of the vocabulary. Token refers to an instant of that type in the given text. Lemma refers to the root form or the stem of the word. For example, both the words cats with an apostrophe and cats without an apostrophe have the same lemma, which is a cat. It can also be thought of as a part of the speech of the word or the rough sense of the word. Cat is referred to as the stem, while cats and cats are referred to as its affixes. Tokenization, also referred to as word segmentation, converts the stream of the words into a list of tokens. A limitation of tokenization is that it also removes special characters. This means that the word cats with an apostrophe will be split into two separate tokens, cat and s. The tokenizer splits words based on all non-alphabetic characters, which also includes the apostrophe. Once you tokenize a word, you usually remove all the stop words as well. These words have high occurrence frequency while providing little meaning on their own. Sometimes they can be important, for example, in the text to be or not to be, which is composed mainly of stop words, have a certain meaning to it which will not be retained if these words are removed. Removing stop words helps reduce the index size, improves response time, and improves the effectiveness of the algorithm in most cases. Please note that this step is completely optional and depends on the problem at hand. Another policy can also be used that indexes all the words in a document and make decisions about which word to use at the query time. Case folding implies reducing all letters to lower cases. It is another common pre-processing technique. It does not have a drawback. For example, words like General Motors, Fed, or Sale might lose their meaning with companies to normal words when lowercased. This will affect the performance of sentiment analysis and information extraction algorithms for certain scenarios. Stemming is a process which removes the affixes. It attempts to reduce the morphological variations of words to a common stem. This usually involves removing suffixes. In most cases, the morphological variations of a word have the same or very similar meanings. The most popular algorithmic stemmer used in information retrieval is the Porter stemmer, which is used since the 70s. It produces stems, not words, and makes several errors and is difficult to modify. This table gives a couple of examples for how the Porter stemmer works.